Right, this video here we're going to be looking at experimental probability. So last lesson we looked at theoretical probability, so the chance of something happening. Now we're going to actually look at when we conduct experiments, the actual results, and that's what we call experimental probability. So first what I want you to do is I want you to conduct a little experiment in yourself. So we know that if we flip a coin, so we've got a 50-50 chance of it landing heads or tails. I want you to see if you actually flip a coin 20 times, and I want you to tally the results. So I want you to tell me how many times heads actually comes up when you flip a coin 20 times. Once you've done that, I want you to answer these few questions. So, how close is the total number you would expect that is based on probability? So, we know that probability, the tail should land around 50 times. Most cases, this is not necessarily the case. It might be more or less. And I want you to discuss what that means. So, I want to see that at the top part of your notes, so that tally and just that answering that question. And then then you'll move down and we'll answer these notes from here. So, pause the video here, do that experiment yourself, and then we'll come back and take those notes. Okay, so now we're going to get into the key information, and I'm going to explain what experimental probability is. So you're going to need to write down all these notes because they are quite important. And we'll start with the experimental probability. So the experimental probability of an event occurring based on a particular experiment is defined as this. So you're going to need to write this rule down. And it is a division rule. So the number of times that the event occurs divided by the total number of trials in the experiment. Okay, so that's how we do it. So it's a number of times the event occurs, so how many times this head occurs, and the total number of trials in that experiment. So in this case, we'll do divided by 20. You also need to write down that the expected number of occurrences is the probability, so this part here, times the number of trials. And this is the expected number if we want to extend that from there. And finally, if the number of trials is large, then the experimental probability is likely to be as close to the actual probability of an event. Okay, so now that you've got that written down, let's do some questions down here, and I'll show you how we want to answer these questions in our book. So to start off, we have A. Okay, first off we have A. So what is the experimental probability of getting a 3? So when we've done a spinner with the numbers 1 to 4 in it, the actual results were as follows. Okay, that's the actual results. Now we want to find out what the experimental probability of getting a 3. So if we go back to the rule here. So the rule is the number of times the event occurs. How many times does 3 occur? We have 1, 2, 3, 4. It occurs 4 times. And how many times does it total trials in the experiment? So there's a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it occurs 4 out of the 10, which we know, simplifying our fraction, is 2/5. So that's the experimental probability. Now we can do the same thing for what is the experimental probability of getting an even number. So we just need to count up the even numbers. We have 1, 2, and 3. So a total of 3 out of 10. And that is our fraction there. So again, remember, it's the number of times it actually occurs and how many trials in that actual experiment. Now this last one here, based on this experiment, how many times would you expect to get a 3 if you spin 1,000 times? So here we're going to use our expected number result, okay, our trial here. So remember, it is the probability times the number of trials. So the 3, we've already looked at the probability, it is 2/5. So the probability of occurring was 2/5, and we're going to times that by 1,000, and we know that our answer for that is about 400. Okay, so when you have the expected number, so if you read this question, you need to then times the probability, which we worked out in part A, times by 1,000. So this helps us get an answer for larger experiments that we do. Okay, so make sure you have those notes written down, and I want to see those experiments that you have done, and we'll go through these questions in class. Thanks, guys.